Okay, good afternoon, everybody, and welcome back to Emory Climate Talks. My name is Eri Saikawa, and I'm an associate professor of environmental sciences at Emory University. It seems slightly crazy that it is already the end of July. The pandemic and the recent Black Lives Matter movement have definitely left many of us pause our lives in different ways. But I am very glad that you came to join us again today. Hopefully to move forward a little bit. This webinar series is made possible by our anonymous donor that supports our trip to the UN climate change negotiations. And Emory Climate Talks is in partnership with the Department of Environmental Sciences and the Resilience and Sustainability Collaboratory at Emory University. Okay, I am going to show the website that we have so that you hopefully know where to find the information of the future talks. So this is our website. If you can go to this climatetalks.emorydomains.org/webinars, you see today's, and then you see the future webinar that's coming up, and you can sign up for our newsletter right here. And if you go to the front page of this website, you will see that you can actually subscribe to our Climate Talks YouTube channel right here as well. So I hope you can do that and listen to the previous talks. We are recording today's talks as well, and we will make that available in the next couple of days on the YouTube channel. For the recording purposes, we have muted your microphone, but if you have any questions during the talk, please feel free to use the chat function below to type up the questions so that I can raise them during the Q&A session. Today, I'm so excited that we're joined by Mr. Shan Arora, and we get to have a virtual tour of the Kendeda Building for Innovative Sustainable Design at Georgia Institute of Technology. Mr. Arora is the director of the Kendeda Building for Innovative Sustainable Design at Georgia Tech. I will share the flyer for today's talk so that you know what I'm talking about. So Mr. Arora is the director of the Kendeda Building for Innovative Sustainable Design at Georgia Tech. The Kendeda Building is a multi-disciplinary, non-departmental education building. Many of you might know the Kendeda Building as a living building, and that is because it is pursuing the Living Building Challenge, the world's most ambitious building performance standard. As the first regenerative building of its scale in the Southeastern United States, the building sets a new standard for design and construction in a region known for temperature extremes and humidity. The project's goal is to transform the built environment in the Southeast by advancing innovation and by showcasing synergies between environmental stewardship, social equity, and economic development. I'm sure Mr. Arora will tell us all about the building and what it does and how it's built in today's virtual tour. Although he is now working at Georgia Tech, Mr. Arora has a bachelor's degree and also a law degree from Emory University. He is currently on the board of directors of Georgia Interfaith Power and Light, a nonprofit that engages communities of faith in stewardship of creation as a religious response to climate change, resource depletion, environmental injustice, pollution, and other disruptions in creation. Prior to joining Georgia Tech in July 2018, he was with Southface Institute, where he worked with local and regional partners to increase the amount of clean energy generated in Georgia, promote energy efficiency in the built environment, and expand the region's clean energy workforce. We will actually have Mr. Jeff Foote from Southface Institute next Monday, August 3rd, to hear more about what they do. So I hope you will come back to listen more about that. Most importantly, Mr. Arora was the head quarterback of their undefeated football team for a record 7 seasons at Emory. So he is truly the champion of sports and environment, and I'm so excited to have him today. After the virtual tour, we will open up for questions, and as mentioned earlier, please feel free to jump in with any questions at any time in the chat box below, and I will get to them at the end of the tour in the talk, or maybe during the talk as well. So with that, thank you so much, Shan, for joining us, and I'm so excited about the virtual tour.
Thank you so much. And hello, everybody. Thank you for your time. I am here at the Kendeda Building for Innovative Sustainable Design. And as you can see, there's not a lot of people here, so it's easy to get social distancing. But just in case we have a sudden rush, I do have my mask here with me. So today, I don't want to spend the entire time talking. I really would like for it to be a conversation. But there are three things that I want to make sure that I impress upon you. The first is that buildings are part of the solution. The second is that we need to do more with one idea. And the last thing is solutions equal economic opportunity. So these three things, these three themes, you will hear me saying over and over again, that buildings are part of the solution. We have to do more with one idea, and that solutions are an economic opportunity. And in case you don't already follow us on social media, you can find us at Kendeda Building on Instagram, Facebook, LinkedIn, Twitter, and soon YouTube. So with that, put my sunglasses on. We're going to go outside because it is a lovely, hot, humid southern day. Hot, humid southern day. And so that actually gets me into why this building exists in the Southeast, why this building has gotten so much attention. But let's step back first and let's talk about the Living Building Challenge, which is the certification standard that this building is trying to achieve. You know, we've got lots of green building standards, the most famous of which is LEED, Leadership for Environmental Engineering and Design. Emory University leads in LEED certified building. It's one of the top universities in the country, if not the world, for LEED certified buildings on campus. But these green certification standards, LEED and Southface's Hvac standard, what they've done is they have really moved the market. They have moved the conversation about what buildings do to the environment, what buildings do to the health of occupants, and they have resulted in buildings that are better for the environment and better for occupants. But in a resource-constrained world, in a world where we have climate challenges, is it enough to do better? And the answer the Living Building Challenge gives is no. It's not good enough to be better. We have to be good. Better is not good enough. We have to be good. So the Living Building Challenge asks the question, what does good look like? And I like to say the Kendeda Building is what good looks like. So let's talk about the Living Building Challenge basic framework. The Living Building Challenge basic framework, the ethos of the Living Building Challenge is a flower. Because if you look across nature and look at something that nature has that gives back more than it takes, right? If we want our buildings to do good, they should give back more than they take. And that's what flowers do, right? Flowers get everything they need from the site in which they are located. All the water, all the light, all the nutrition comes from this site. And what they give the world is seeds. So they actually give back to the world more than they take, because when they leave, when the flower leaves, there's almost no trace that it was ever here except for the seeds, more life. And so that's the framework. And then like a flower that has petals, the Living Building Challenge also has petals. The petals of the Living Building Challenge are the performance areas. And there are 7 performance areas or petals of the Living Building Challenge. And they are place, water, energy, health and happiness, materials, equity, and beauty. So those are the 7 petals of the Living Building Challenge. And you got to do all 7 of them. That's why it's called a challenge. And the reason you have to do all 7 of them is that if you start pulling apart the petals of a flower, the flower falls apart. The flower ceases to be what it is, and it ceases to be able to do what it's designed to do, which is to give back more than it takes. So we say, in order to be a fully certified living building, we got to do everything across the 7 petals. And that's what makes the living building challenge such a challenge, but that's also what makes it really compelling, and quite frankly, why we're here having a conversation about this building. So that gets us to why this building is here. There are only 26 fully certified living buildings in the world, and the vast majority of them are in the Pacific Northwest and the Northeast. They're not here in the hot, humid South. If you're outside right now, you're probably uncomfortable like I am. And that's exactly the point. You know, a living building, in order to be a fully certified living building, you have to do a lot of things, but one of them is that you have to generate more on-site electricity from renewable sources each year than you consume. And you have to get all your water for drinking, your water for your faucets, your water for shower. You got to collect it from on-site rainwater, and you've got to treat all your water. That's your gray water, your black water, so the stuff that goes down your sink, the stuff that goes down your toilet, you got to treat it on site. So when people hear that, they think, can't do it in the Southeast. It's too hot, it's too humid, you'll never build a building that generates more on-site electricity than it consumes per year in the hot, humid Southeast. Challenge accepted. And that's how the Kendeda Building for Innovative Sustainable Design came to be. The Candida Fund, which is a local Atlanta family nonprofit, provided 100% of the funding needed to design and build this building. So while it is on state property and while it is a Georgia Tech building, the funding to construct it and design it was 100% provided by the Candida Fund. And that's because this thing is like an R&D project. It's designed to prove to people that it can be done down here, right? And so the thing that I've learned in environmental policy is that there's going to be a lot of reasons why people say something can't be done. And one of them is that it's just not technologically feasible here in the South. Oh, that'll work in the desert. When it comes to solar power, they said, oh, that'll work in the desert, but it won't work here. We got too many clouds. Well, once you start showing them examples of solar in the South, solar in Georgia, you take the it can't happen here off the table. So that's one of the goals that we have with the Kendeda Building. In order to be a fully certified living building, you have to show actual performance for 12 months. So in addition to doing everything that you got to do to get certified, you then have to prove that during the operational period for 12 months, you generated more on-site electricity than you consumed, and that you got all your water from rainfall. We are not yet done with our 12 months of fully occupied, but I gotta tell you, December, January, February, and most of March, before the COVID disruption kicked in, we were net positive when the building as modeled, net positive energy, when the building as modeled was designed to actually be net negative, meaning we were designed to consume more electricity from the grid than we generated on site for the months of January, February, and we were in fact net positive. So we think that we have, at the end of the performance period, we'll prove that we can be net positive, and therefore we'll take any argument of this can't be technologically done in the Southeast off the table. So with that, I'm going to pause and see if anyone has any questions.
I don't see any questions yet, but if you have any questions, please feel free to write in the chat box.
Okay.
I was curious if I could ask, so what would be, you think, the biggest challenge to meet this challenge?
I think the biggest challenge we have when it comes to anything that we do with the environment is our unwillingness to even try, right? It's our unwillingness to just think big. And I'll explain that answer in a minute. I mean, there are a lot of other things that go into not just this building, but the climate solutions. But again, I think that every single solution is an economic opportunity. And our biggest challenge that we have is our inability to think creatively and think of the solution as an opportunity. The question was asked also, what's the Kendeda Building used for? It is a non-departmental classroom. And that is also part of the ethos that Georgia Tech wanted to put forward, is that we didn't want this building just to be a space where architecture students came, or design students, or physics students. We wanted to be a place where the full spectrum of coursework at Georgia Tech has the opportunity to cycle through this building, because we want the creativity, the cross-pollination that comes from having physics students talk to biology students, to talk to some of the liberal arts folks. Yes, Georgia Tech does have more of the liberal arts type stuff, policy classes. It's getting that variety of viewpoints together to solve the major challenges that we have when it comes to environment. And that's what we wanted. We wanted that the cross-pollination. And to go back to the flowers, the seeds that come out of those conversations, where they will get planted, where they will germinate, we're not sure. But we wanted to give students the opportunity. Someone else asked a question. It was about funding, I think.
Yes. So there's a question, if the building was fully funded by the Candida family.
One moment.
Sure.
Excuse me. Right next to the water fountains. Yeah. Sorry about that.
Sure. Yeah, this is what happens when you're actually giving the tour and then everybody's looking for you for the information. But so yeah, there was another question, if the building is fully funded by the Candida family, and if you're able to disclose how much it costs to construct.
Oh yeah, absolutely. It's 100% funded by the Candida Fund. It costs $25 million. Well, the construction grant was $25 million. And then there's up to another $5 million for programming.
So another question came, if there were to be lab spaces in the building pursuing the Living Building Challenge, would waste products produced on site have to be treated as a part of the challenge requirements? And would this limit the feasibility of pursuing this challenge on a bigger scale?
So we actually have 4 teaching labs, but notice I said teaching labs and not research labs. So all the pedagogy that occurs in the building, including the lab, has to fully comply with the Living Building Challenge. So all the materials that go into the lab have to comply, and then all the waste coming out of the labs has to comply. I will be more than happy to take some additional questions. These are great questions, but I'm going to jump right in now to the next portion of the tour, which is what I said, buildings are part of the solution. So I'm stepping far away so you can see this building. You can see the solar canopy. You can kind of start understanding that this is a special building designed to do more than an ordinary building. So it is part of the solution. But 20 things go into everything that has to be done. So those 7 petals have 20 subtopics that are called imperatives. And every single one of those imperatives has to be met. And therefore, every one thing that you do has to satisfy at least 2, if not 3 of those imperatives. Otherwise, you're going to bankrupt the project. It's just going to be out of the realm of possibility. So another way I like to think about that is that single-use infrastructure is a luxury we no longer have. This is a road that is adjacent to the Kendeda Building. And this is a lovely road. It has bike paths. But what is this road doing beyond facilitating the movement of vehicles and bicycles? What is this building doing to prevent rainfall from becoming a nuisance. In other words, preventing rainfall from becoming storm water. What is this building doing on a hot day like today to decrease the urban heat island effect? So this is single-use infrastructure. It has a byproduct, which is stormwater, for which we build additional infrastructure. And that infrastructure is expensive, and sometimes that infrastructure fails. It produces externalities downstream. And I'm standing in the middle of the street, and wow, I wish there was some mitigation of the heat island effect. And then we've got the site of the Kendeda Building. And as soon as you step onto the site of the Kendeda Building, you will see that the concrete just changed. What's this? What's this? Oh, it's porous concrete. So when rain falls here, it doesn't become stormwater, it gets absorbed. And you'll see all of the other things that we've done to manage rainfall, just like that clump of trees over there manages rainfall. Because that clump of tree, that represents the Piedmont forest, which was here before Georgia Tech was ever built. That clump of trees over there manages 90% of an average rainfall on site. And therefore, the Living Building Challenge required the team to design a space that manages 90% of rainfall on site. Now, before the Kendeda Building was built, this was a parking lot. And now it is a building with exterior space. You might be asking, well, how does a building that is 37,000 square feet indoor with another 10,000 square feet outdoor, how does this building manage 90% of the water on site? Well, it starts with those solar panels. Those solar panels and the roof collectively manage 40% of the rain that falls, and it goes into an underground cistern. And then 60% that falls out here, the remaining 60% is managed outdoors through bioswales, which are these little depressions. So when water falls, instead of rushing downhill, they collect in these basically ditches, and the water slowly seeps into the ground. And then we've got pervious concrete, we have pervious pavers. Now this becomes a very important equity issue because water goes downhill. Stormwater, therefore, goes downhill. And in a normal rain event, if you've got a lot of impervious space like parking lots and roads, that water is going to go downhill and it's going to flood the communities that are downstream. And oftentimes, especially in our region, the communities that are downstream are communities of, well, let's just say, less economic mobility. So that's rainwater. Another type of water is gray water. And that gray water is what goes down the sink, what goes down the shower drain. And our gray water system is right here. You're taking a look at it. It's a constructed wetland. So we pump all of our gray water into a constructed wetland, and we let nature right here break the matter down, the organic matter. Not only is it a very low energy and a natural way of managing gray water, it also creates a beautiful amenity. Another thing that we do for water is our HVAC system. We collect the condensate from the HVAC system. And in fact, we don't have an HVAC system. I call it HVAC because it's easier to explain it this time by just saying HVAC. But we collect our condensate, store it in a tank. Thank you. Store it in a tank, and then thank you, ma'am. Thank you very much. We store it in a tank, and then we use that for irrigation. The last thing, of course, is the stuff, the poo and the pee. I say there's a lot of potty talk in the Candida Building. because there's no tour of the Kendeda building that's complete without going to the bathroom together. And then from that point onward, the conversation usually sticks to poo and pee. And you'll see why when we get there. So again, at this point, I'd like to pause, because what I've really done is I've talked about place, I've talked about water, I've introduced solutions to problems. One of those problems is downstream flooding. And this is a solution to downstream flooding. In a normal rain event, we're going to manage that water on site. And then I've also talked about how one idea, we can do more with it. So the one idea is generate enough on-site renewable energy so to where you don't have to take electricity from the grid over the course of a year. And I've mentioned our solar canopy, but haven't mentioned the fact that it is used to generate electricity. I've in fact mentioned it in the context of collecting enough rainwater to satisfy the water requirement. So there's a question that just came in. Let's answer a few more questions and then we'll continue with the tour.
Great. So one of the questions is, how big is the Candida building? I think you've answered some of that.
Yep.
And how does that compare to other living buildings?
So it's 37,000 square foot indoors, another 10,000 square foot outdoors. And insofar as living buildings are concerned, it's on the bigger side. It is on the bigger end of the living building spectrum. But I also do want to emphasize, we're not quite living building yet. We are still in the process of undergoing our certification, but yes. Oh, and I don't know if you just saw that the amount of light in here changed. That's because those blinds automatically came on, because rather they automatically opened up to allow more light into the building.
Oh.
Yeah.
Another question is, can you talk more about the feasibility of expanding living buildings to more dense urban environments where the space for the solar canopy may not be available?
Oh, that's a great question. So if you take a look at the Bullitt Center, which is the very first fully certified living building in the world, that is in the middle of Seattle. And they have a solar canopy much like ours, which is an overhang. So it actually comes over the building. And then there's a new building that has come up in Portland, I believe. It's the PAE headquarters. And they actually have also managed to get enough on-site solar. But that's actually true, you know, where you have vertical buildings and there isn't a lot of space for on-site renewables, that can be a challenge. But let's just step back and remember that the goal isn't necessarily to get every single building constructed to Living Building Challenge. Beyond the Living Building Challenge, there's something called the Living Community Challenge. Because what we've done here at one building level, a lot of what we've done would make a heck of a lot more sense at a community scale, right? And that's especially true when we talk about the water solutions that we have. And so I'll get to that some more, but let's start thinking district scale. And that also gets us back to job opportunities. Let's think about district scale energy production. Let's think about district scale water purification and water management. And that is actually also economic opportunity. One more question, and then I'm going to talk about buildings as a solution a little bit more.
Yeah, sounds great. So another question is, does Living Building Challenge require a native landscape plant?
As much as possible, yes. You can find out more at our livingbuilding.gatech.edu website. And if you follow us at Kendeda Building across the various social media channels that we have, we're often posting pictures of our native landscape because right now it's in full bloom.
Sounds great. So we let you continue and then we'll keep up with another questions later.
Okay, so I'm going to check in at this point. Can you hear me just fine? Am I moving too fast? I want to make sure that it's good.
I think we're good.
All right. Well, I'm going to take this off of my face. That's not what you came here to see. So here is the building. And again, I could talk about it forever. There's so many stories here. but I do want to show you where 50,000 gallons of rainwater is stored. 50,000 gallons. We are on top of 50,000 gallons. Okay, so here we are. This is one of my favorite views of the building. What you are looking at right now is a building that is very thoughtfully considered solutions to climate change. It might not be obvious to you, but this vantage is chock full of solutions. The first solution you definitely can't see. It was extremely hot outside, and inside there's no air conditioning. Not here, not in the vast majority of the space in the Kendeda Building is there anything that even remotely compares to what we would consider air conditioning. And it is extremely comfortable in here right now. So how did we get there, you might ask? The first thing you got to do is create a building that's extremely energy efficient. This building is 72% more energy efficient than an average building of its type in this climate zone. And the reason is because A, we built it really well. There's very few leaks. Those windows that you see up there and there and there, triple pane windows with argon gas in the middle. So they're very efficient. We've got the right amount of insulation, not too much, the right amount. And then what we have done, because the building is so incredibly tight, we bring in a lot of outside air. And what we do with that outside air is that we precondition that outside air. You can maybe see the system. Nah, you can't, but it's on the roof. It's on the roof right there. And we're bringing in outside air. So you see all of this ductwork? That ductwork is not air conditioning. That ductwork is preconditioned outside air. So in a day like today, where there's so much heat and humidity outside, we're bringing in that outside air and we're taking the cooler, less humid inside air and we're exchanging it. We're doing a thermal exchange to where the outside air gets less humid and the outside air's temperature drops. And then we're pushing that into the building. In the wintertime, it's reverse. And then we've got these giant fans. They're actually called big ass fans. That's the name of the company. Right now, we only keep one big ass fan on, and then we keep all these smaller fans on. And what that does is it creates this nice breeze inside the building, and it keeps us extremely cool. When we do need to get some help for cooling and for heating, we look down here. Underneath the concrete, we've got pipes. And in the pipes, we have either hot water or cold water that runs through. And what happens is when we need the building to be cooled, we will radiate coolness. And when we need it to be warm, we'll radiate warmth. The advantage there is we use concrete's thermal properties to keep the building hotter and cooler. And so on top of that really efficient system, we put 330 kilowatt solar system that gets us to net positive energy. The solar system generates about 450,000 kilowatt hours a year, and the building is rated to consume about 300,000 plus kilowatt hours a year. So yeah, we are going to be very comfortably net positive. So that is part of the solution story, right? We are operationally going to be net energy positive, not the first year, not the second year, but as modeled for 25 years. That doesn't necessarily correlate to a zero carbon footprint building because there's still embodied carbon that goes into building and constructing. But from an operational perspective, we will be net positive energy. Not net negative carbon, net positive energy, but we're still moving in the right direction. On the embodied carbon perspective, one of the things that we have to do for the Living Building Challenge is get to a place where, okay, I'll answer the energy storage and the Atlanta grid question in a minute. We have to get to a point where the embodied carbon of the building is as little as possible. So one of the first ways that you can reduce the embodied carbon of a building is to incorporate salvaged material. So here in this ramp, we've got salvaged wood from a building that had to get deconstructed to make way for Georgia Tech's new police station. Over here, we've got we've got wood beams from the very first building Georgia Tech ever made, which is Georgia Tech Tower. That building was made in the 1880s. So the wood that was cut, the trees that were cut down, I mean, they began their life in the 1700s, early 1800s. And normally this would have just been thrown away. And instead we salvaged it and turned it into this beautiful monumental staircase. All of the, oh, by the way, y'all are some of the first to get a view of this. Our permanent signage just got installed last week. Ooh, ah, so here's our permanent signage. But this is a tree that fell down on campus due to natural causes. Instead of being mulched, we turned it into furniture. This was also a tree that fell down. We turned it into furniture. And so every time you incorporate salvaged material into the building, into any building, you are taking advantage of the embodied carbon in that product. So one of the interesting things about the term embodied carbon is that a lot of people don't understand it. So I've stopped calling it embodied carbon and I've started calling it embodied carbon pollution, right? Because I think people understand that. So when you take something that already has some embodied carbon pollution in it and you're reusing it, the embodied carbon pollution that's in it is kind of locked in it, right? You're not creating any more. You're actually taking advantage of that. And by reusing it, you are, every year, the carbon impact of that product starts getting less and less and less. So that's one way that this building serves as a solution. So let me step back. The Living Building Challenge actually has 3 net positive requirements. One is net positive water, which we've talked about. One is net positive energy that we've talked about. And the other is net positive waste during the construction process. In the United States of America, about 40% of everything in a landfill is from construction and demolition debris. Think about that, 40%. And what we've shown here in the Candida building is that some of that material can be reused. So this gets me back to my 3 points. The last point is solution as an economic driver. People always say, well, what's the cost? What's the cost? Labor cost. Absolutely, there is an added cost to this. To decommission a building and salvage from that building materials that can be reused is a cost, but it's a local labor cost, right? And especially now when there's so many people unemployed, wouldn't it be great if we could create an entirely new sector in our economy that put people to work, kept things out of our landfill, and is part of the climate solution? The climate solution thing is the cherry on top. That's the cherry on top. And then let's get back to point number 2. You got to do more with one idea. This beautiful ceiling right there, that beautiful ceiling is doing a lot of things to help us get to our Living Building Challenge certification. Let me just count the number of things that it's doing. 1, it's beautiful. At least we think it is. What you're seeing is 2x6s and 2x4s that have been very painstakingly nailed together to create this beautiful ceiling. And why do we focus so much on beauty? Well, the Living Building Challenge says that you got to create things that are beautiful because let's just face it, people like to preserve things that are beautiful. So we think it's beautiful. The second thing it's doing is it's made out of wood, and wood, of course, stores carbon, and it's locally sourced. It's from Alabama. So it's within 1,000 kilometers of the site. The Living Building Challenge has a requirement that 50% of all the goods that are in the building have to be sourced within 1,000 kilometers. That's to both decrease the vehicle miles traveled and therefore reduce the carbon impact, but it's also to encourage local economic development. So that's 3. 4, the trees were sustainably grown and harvested. 5, 25% of the smaller beams, the ones that are in the middle, those 2x4s, 25% of those smaller beams were from Atlanta's film industry, and they would have been thrown in the garbage. So what we did is we salvaged them and incorporated them into the building. And then you see these bigger pieces, the 2x6s, the end pieces we turned into those stairs. And in that way, we prevented more items from going to the landfill than we sent to the landfill. Right? And I haven't even talked to you about the equity considerations. I'll just tell you real quick. Equity is a component of the Living Building Challenge, and we've done a lot of things that are required by the Living Building Challenge for equity. For example, this ramp right here is in the right when you walk in. Right when you walk into the building, you'll see stairs and you'll see a ramp. My father was disabled, so growing up, I know where the ramp was. It was hard to find. It was out of the way. It was an afterthought. Here, it's right in the middle because we want people that either want to use the ramp or have to use the ramp to have as similar of an experience as other people as possible. But we said, there's more that we can do with equity. And we started thinking about equity in the context of workforce development. So 6 men who went through a program that's done by a nonprofit called Georgia Works. It's a nonprofit that focuses on helping men at risk of chronic homelessness get off the street, get housing, get healthcare, get nutrition, and get workforce development. 6 men from Georgia Works helped build that ceiling. And they got marketable skill sets and one of them went on to get a permanent job with our general contractor, worked for the general contractor for a while before he got presumably a better offer at a competitor. So any questions at this point before we all go to the bathroom together?
So one of the questions is, has there been a learning curve for building and facility maintenance due to the unique systems like energy, mechanical, wastewater, et cetera, used on the site?
Absolutely. But it's been, I'm sorry, my audio is getting a little funky. Can y'all hear me okay?
Yes, we can hear you.
All right. Yeah, there is a learning curve. It's new, right? But it has not been a learning curve that's been so extreme as to be prohibitive. And again, that's part of why we're doing this here, is that we are the first building a building of this scale seeking Living Building Challenge certification in the Southeast. And what we learn from this is going to help the next facilities team for the next building that's trying to get Living Building Challenge. I mean, the learning curve is going to get less and less and less. So I just wanted to bring you guys up here real quick before we go to the bathroom. We also have a rooftop garden. We have an apiary up here. We've got, wow, our corn. Wow, I just got to take you out there. Our corn, our squash, and our sunflowers are coming in. We just had blueberries that bloomed. sometimes my card works. In the meantime, let's ask another question.
Yeah, so I think you were trying to getting to this, but does energy storage occur on site or are there exchanges with the Atlanta energy grid?
Both. So energy storage is on site, but the energy storage is really, I don't know what's going on. The energy storage is really just for resilience. Oh.
Sorry, I don't hear you anymore, but is it me? Oh, there we go. We didn't hear you for a while. I don't know if it was me or you. Can you hear me?
Yes, how about now? How about now?
Okay, yeah, that's great.
Yeah, whoever sees this on YouTube is gonna be like, wait a minute, I see this guy's hand a lot. Listen, I'm multitasking here. All right?
know, we appreciate that.
And this is how you know it's not scripted. I will answer that question, but I need to show you all this. This is awesome. This is our we have an urban gardening requirement. It's not for the purposes of being self-sufficient with food, but it's to connect people back to food. And in the distance over there, you'll see our sunflowers. And then over here in the middle is corn. Right there is squash. These are blueberry bushes. Those are all flowering plants that help feed our bees that are back there. How awesome is that, right? Okay, I'm just gonna assume everyone on your end said, yeah, that's awesome. But we do feed excess electricity to the grid, but the grid here is really Georgia Tech. So our master meter for Georgia Power is, we have one master meter for Georgia Power. So all the excess electricity that this building generates is really consumed by the buildings that are right next door. So I'm just showing you one of our classrooms. This is one of our classrooms right here. 64 people can fit into this classroom. Again, right now, it is exceedingly cool and exceedingly comfortable in here. And there's no conventional AC. Over there, you'll see a class lab, a class lab, a class lab. There's a class lab down there. That's a conference room. My office and other shared offices are back there. And then there's a 170 person auditorium over there where it's dark. Okay, so there's a few more questions that were asked. Let's answer those questions while we all go to the bathroom.
Okay, great. So the question is, what did the design process for the building look like? How were community voices included in the planning design process?
Okay, what did the design process look like? Wow, it was long. I mean, it started way before I got here. I have been here for 2 years and 1 week. I just celebrated my anniversary. And so the design process actually began with something called we had a design competition. So 3 design teams received a stipend to present their design. And then we selected one. The idea of doing a design competition was that once you learn how to design and build a living building, you can't unlearn it. So Georgia Tech and the Candida Fund viewed the design competition as a way of magnifying the knowledge exchange for the living building across more than just the winning team. All right. Then community voices. Yeah, there were opportunities for community voices, but most of the community in our case was the Georgia Tech community. Okay. So there were opportunities to have other folks in the Georgia Tech community provide input on what they wanted. And then we also had pilot projects where we gave funding to professors and students to do these smaller pilot projects. And one of the pilot projects was a virtual reality pilot project where they took the CAD designs, the architectural and engineering designs of the building, and created like this virtual reality walking tour. And the idea is that that type of concept can be taken to the broader community before something is ever finalized, and the broader community can get an opportunity to virtually go through a building or virtually go through a development, and through their lens, their experience, their perspective, give feedback of like, wait a minute, that street's not going to make sense there, or this ramp is too steep, or it'd be better to place something else over there. So I hope that answers your question.
Yeah, that's great. The next question is, in the winter, what's the temperature like inside the building?
Well, okay, so it was cold when the floor wasn't working properly, but when the floor is working properly, meaning when the radiant heating is working properly, it's comfortable. Now I'll say this, people have a different tolerance level. 25% of the people in a building at any given time are going to be uncomfortable. It's actually not wintertime that you got to be careful about in the South. It's the summertime. Because how many of us have gone to a building in the middle of summer and it's absolutely freezing? And the reason it's absolutely freezing is because they're using air conditioning to dehumidify the air. What's really uncomfortable for us in the summertime is the humidity. So what we do is we have a dedicated outdoor air system that dehumidifies the air, and that actually allows us to have a higher indoor air temperature at which we're still comfortable. So people typically aren't freezing in this building in the summertime. So it's odd, when you really think about times of the year when you're freezing indoors, it's the summer, right? All right, at least that's my perspective. All right, so real quick. This tile came from the roof of the Georgia Tech Alumni House. This tile was put on that roof in the 1920s. The roof had a leak. This tile had to be taken off. Normally, this would have been thrown away. We salvaged it and turned it into part of this beautiful wall. Yet another example. This tile and the wood outside is going to outlive all of us. I'll explain this. We have temporary water right now because we're in the final stages of getting this building up to potable drinking standards. So right now this water is turned off because the water that comes out of here is going to be, still needs to be certified by the Georgia Environmental Protection Division. All right, this water, this right here, foam flush toilet. I tell people, if you want to help the global climate crisis, use this toilet right here. Use this toilet because, and people look at me this morning, what's this guy doing? Use this toilet because let's step back and think about how much electricity it takes to get drinking water to the toilets of a building like this. First, you got to get the water from, in our case, Lake Lanier, Lake Allatoona, or reservoirs. That takes electricity. You got to pump that water to a central water treatment plant that then uses more electricity to get that water to drinking standards. And then we use more electricity to pump that water to buildings all across the area. And in buildings like the Candida Building, commercial buildings and classroom buildings, the vast majority of that drinking water is used to flush poo and pee down literally down the toilet. 60-something%, about 67% of Georgia's electricity comes from burning fossil fuels. All right, it varies depending on what time of year, but it's about 67%. So now, not only have you taken what's otherwise perfectly good drinking water and poo and peed in it and flushed it down the drain, it's also got a lot of embodied carbon. Then that wastewater we use electricity to convey that wastewater to a central wastewater treatment plant where we use more energy to convert that wastewater into a standard that's good enough to discharge into the waterways. And if you're from Atlanta, you know oftentimes we fail and we are dumping partially treated sewage into our waterways, which is both an ecological and equity issue because the people who are downstream have to deal with our wastewater. That's a ridiculous scenario. It's a ridiculous situation. I think we can all agree that we shouldn't be pooing and peeing in drinking water. So the way the Kendeda Building, I just want to show you right now, this is, we are comfortably net positive right now. The building is using about as much electricity as a small home right now, a home, and producing a lot more electricity than it's consuming. So back to the water, this is our water treatment skid. Once we are certified by the Environmental Protection Division, we will be the smallest municipal water system in the state of Georgia. Behind that wall over there is 50,000 gallons of water. We get that water, we treat it over here, we put that into two 25,000 gallon tanks. And once we are certified, we are going to use 1 teaspoon of water. That foam flush toilet only uses 1 teaspoon. And if you sit there for a long time, a couple of teaspoons, because it's motion activated. The foam flush is motion activated. A couple of teaspoons, a tablespoon, what does it matter? We're using a minuscule amount of water, and the water that we do use is from our site, and the electricity we're using to get that water drinking standards is coming from our solar system, right? So think about think about the carbon impact. What's the carbon impact? And then that's the story of getting the water, low carbon, virtually no carbon water to our toilets. Then the other part of the equation is the wastewater. So what happens to that poo and pee that we foam flush down that toilet? What stays here for the most part? It stays in these giant bins behind me, one of 6 bins. And once I show you the actual product, you are going to be quite amazed, because that's it. Now, granted, we haven't been open for a long time. After about 5 years, that is going to probably fill up to here. So what happens is our waste comes into the bin. Up there, we've got sawdust. And you can see the rake. We've got rakes. It's sawdust up there. Most of your biosolid is itself liquid. So the liquid goes through the system and eventually hits the sump pump and then gets pumped to this 1,000 gallon or this 1,000 gallon tank. So here we've got 2,000 gallons, and this contains what we call the compost tea. It's a euphemism for basically leachate. It's human compost water. It takes 1 month. When the building is fully occupied, it takes 1 month to fill up 2,000 gallons. Think about it. Your average commercial toilet, 1.6, even if it's super efficient, 1 gallon per flush. Let's just say it's 1 gallon per flush. That means 2,000 flushes, less than 2,000 flushes actually, would fill that up. Instead, it takes us 2 months to fill up, 1 month to fill up 2,000 gallons. And then what do we do with that? This gets trucked to North Georgia, North Atlanta, I should say, where it's turned into compost. It's turned into fertilizer. Again, let's think through the multitude of benefits. For just the water side. We're managing water on site, rainfall on site. We're decreasing the burden to the infrastructure, the stormwater infrastructure. We're decreasing the impact to downstream communities that are disproportionately impacted by stormwater runoff. Then on the wastewater side, we are using potable water that we are creating right here on site, using rainwater on site and on-site renewable electricity for foam flush toilets that use this much water per foam flush. And then we are treating that human waste on site and producing very little material that needs to be shipped off-site for getting turned into fertilizer. And more importantly, we don't connect to the sewer. We're adding no burden to the sewer. So think about it. That's why we talk a lot about, that's why there's a lot of potty talk in the Kendeda Building. We don't connect to the sewer. So I'm going to open it up to questions again. But before I do, I want to just go through the 3 points that I wanted to make. And hopefully I've made those 3 points convincingly and clearly. Point number 1, buildings are part of the solution. Point number 2, do more with one idea. Point number 3, solutions equals economic opportunity. And then, if you haven't already, at Kendeda Building across all of the social media platforms. Okay, sorry, I sped it up towards the end.
That was great. Yeah, so there's a question. Is the Candida Building going to be the central pivot for future sustainable measures implemented in the Georgia Tech community?
I certainly hope so. We, the project team, certainly hope so. I will tell you this much. The Georgia Tech community, the Georgia Tech administration, Georgia Tech facilities have learned a lot from this building. The facilities team, okay, we've got something called the Yellow Book. The Yellow Book is our internal design guidelines. And there is a committee that meets to update the Yellow Book. And so that committee is moving to take things that we are learning from the Candida Building and move them into the Yellow Book design standard. So yeah, I mean, it's already changed the conversation on this campus.
The next question is, are all living buildings new buildings, or have any been certified through renovations?
Yeah, no, renovations are very much part of the Living Building Challenge ethos. And in fact, if you're going to do a renovation, you know, I said that there's 20 things that you have to do. There's fewer things that you have to do just because you are a renovation building. Some of those things are not practical to do in a retrofit context.
Yeah, so those are the questions that we have so far.
Okay. All right.
If there's any more questions, please write them up. But yeah, it was fascinating. I feel that this toilet, you really have to go to see what's going on, because you have to feel it to figure out how amazing this is. It's a little bit difficult just with the virtual tour. Yeah,
you know, if I may just spend a few more moments talking about that, you know, look, we were talking before this started. I'm originally from India, and one of the things I talk about, or rather think about a lot, is the Candida Building as a solution, not just for the Southeast, but for the developing world. You know, in many ways, the things that we have here in the Candida Building, it's a village scale solution, right? So if you take a look at a big chunk of the world, what's really needed is electrification and sanitation. And electrification and sanitation has tremendous education and health and happiness outcomes. Education, it's if you are dependent on natural light for education, meaning doing homework, then when the sun sets, you're going to have to either study by a kerosene lamp or candlelight, which has its own health consequences, or you're not going to study at all. And so if we could electrify the rest of the world and do it without burning fossil fuels, that would be pretty amazing. And then on the sanitation side, it's a big problem. Open defecation, the lack of sanitation. As Americans and as people who come from or have lived in fully developed countries for most of their life, we don't appreciate how much of a problem it is for a big chunk of the world. And the Candida Building, if you just step back and think about it, it provides village scale solutions. Like the Living Building Challenge actually provides village scale solutions where we can get village scale on village electricity. You can have a battery pack that's big enough for backup energy when the sun is down. And you have a system to harvest rainfall for use for drinking water and essentially treat your human waste on village site and turn it into fertilizer. So that's kind of like my outside the Southeast using the Kendeda Building as a solution lecture.
Right. And then I think that there's another question. Could you talk about the economics of the building? Please start with cost per square foot versus conventional.
Thank you. Was waiting for that.
The operation living building challenge versus conventional. That always seems to be a hurdle.
Tyler's got to drop off. Thank you, Tyler, for being on. All right, so I was waiting for that. I was like, gee, these Emory kids are killing me here. They're not asking the one question. So usually when someone asks me the economic question, I say, I've never been asked that question before. I don't know how to answer it. No, I'm always asked that question. And it's a great and it's a fantastic question. So let's start by answering the question with a question. What's the cost of not doing something like this, right? Who bears the cost when we throw something away? You know, I've mentioned throwing things away several times during this tour. I've mentioned stormwater going away several times during this tour. Where is away? Away is still on this planet. It's not on Mars. So when we just throw something away, when we flush something down the toilet, when rainwater becomes stormwater and just washes away, there's a real cost to that. And it's borne by someone somewhere. And that someone will be us. And that somewhere is somewhere in the future. So the point at which I begin in answering that question is there. It's kind of preachy, but I feel this building allows me to be a little preachy because look at what all this building is doing. I mean, this building is accomplishing quite a bit, right? So yeah, that's how I first answer the question of cost. There is a cost associated with not doing these. And, you know, in economics, it's called the externalities. Somebody, somewhere is paying for that cost. But now let's step back and look at it from a business perspective, right? There is a business component to this. Cost per square foot, you can go to livingbuilding.gatech.edu. That's livingbuilding.gatech.edu. Go to the About page and you're going to get the cost per square foot information. But ballpark, it's about $400 per square foot when you look at the entire site. And it's about $500 a square foot when you look at the interior site. Not cheap, but keep in mind, this is a college building, and college buildings tend to be more expensive anyway. But here's what I want you to remember. When we compare that with a conventional building, how many conventional buildings have a $1 million solar system on site that's designed to remain net positive energy for 25 years? That's kind of like buying 25 years of electricity up front. And how many buildings that are only 37,000 square feet interior are their own municipal water system? And as designed, this building will meet all of its water needs from on-site collected rainwater. This building does not connect to the sewer. So this building does not have any sewer impacts, none. We don't burden the sewer system. We manage all of our stuff here, right? So there is something to be said about the fact that technically speaking, the water bill is going to be zero in perpetuity. We've got, thank you, David. Thank you for your time. We've got, you know, and I want to be very clear. What I'm about to say, we're not doing it just yet. We are not doing this. But one day, that compost leachate that I showed you, that compost tea, that human fertilizer, the liquid, why don't we find a closer source to go and spray, maybe spray that in the woods? Use that as fertilizer and let nature take care of it. We're not doing that right now. But Southface Institute, where I used to be, they do dispose of their compost tea on site in places where human beings don't walk. And the city of Atlanta is okay with it, and they've been doing it for over a decade. So in that scenario, we're completely dealing with our human waste on site. Okay, so yeah, there are upfront costs, but the cost of water will be zero, water that we get from the grid. The electricity is going to net out for 25 years, and we don't hit the sewer. And then remember all the economic impacts that I was postulating? I mean, I even get to mass timber. If you go to the website, you'll read about mass timber. I mean, there are a lot of things in this building that, if done at scale, are also going to result in can result in more local jobs if we have the right policies.
Yeah, thank you so much.
Yeah, that's my sort of the economic argument. And the last thing I want to say is, this is also the first of its kind in the region. Never, I mean, think of it as an R&D project. And that's why the Candida Fund provided 100% of the funding for the design and construction. It's a risk. The private sector might not be willing to take the risk, neither the public sector. So a foundation came in and said, okay, we'll provide the funding. We find the right partner in Georgia Tech that can disseminate the best practices and findings from this experiment, this R&D experiment. I want to know what the cost of the third, fourth, or fifth fully certified living building in the Southeast is. That's what we need to take a look at. I mean, just most of the people on this webinar right now might be young, but we are doing this on a phone. A phone, and I can afford this phone. 15 years ago, 20 years ago, this would have cost, I mean, this would have been something that we could not have done. And that's because technology, when you scale it, gets cheaper, and you perfect it and you make it better and better and better. And that's kind of our goal with this project. We want to ignite the imagination of other peers in the Southeast. We want to ignite the imagination of commercial builders and say this can be done. And hopefully by the fourth or fifth of these in the region, we'll find that the cost premium is not that much.
Yeah, that's a very good point, and I hope that we can have the next
Payne, sorry,
living.
Friend.
Yeah.
Payne
Oh, I see.
Friend of mine. Yeah.
That's great. Yeah, I hope that the second one is going to be at Emory, and they will have so many of those in Atlanta at the community level, as you're saying. So.
Well, you do have a wonderful student center. It's LEED Platinum. That's an amazing accomplishment. It's such a big building. It's a bigger building than this one. And it's something to be proud of. And just, shout out to Alma Mater. What Emory has done with its solar energy procurement agreement with Cherry Street, I think it's 20 megawatts of solar. The key thing here, it's not a one size fits all, right? What Emory's doing, the approach Emory's taking by having LEED as a standard across campus, and then now having what arguably might be one of the highest amounts of on-campus solar energy in the country, that's good. I mean, it's not a one size fits all. That's, again, there's so many of these little stories. The last thing I'll say is this building can be overwhelming. The Candida building can absolutely overwhelm. But the Candida building is like walking into a restaurant and asking for everything on the menu. You don't need to get everything on the menu, right? The menu is already taking you to a higher level. Some people, their site, someone asked a wonderful question, what if your site can't manage on-site renewables? But maybe it's water, maybe it's materials, maybe it's something else. But we always have to take a look at elevating our buildings. So every single building, new or retrofit, is part of the solution. And it's not a one size fits all, but the mindset needs to be buildings are part of the solution.
Right. And then I think that we have to be always creative, think of some new ways to do things. And then I think that's what the Candida building is showing. So I really love that. And thank you so much for this great tour. We so enjoyed it. And we had the questions throughout the talk. This was the first time, I think, that we were actually able to have the questions answered like in between, and that was really great. So thank you so much for that.
And I hope y'all enjoyed it. You know, I like for it to be casual. So sorry for audio that might have been less than good, and seeing the palm of my hand and my finger several times during the tour. But thank you very much. And, you know, I hope this stuff, you know, calms down, and I would love to give y'all an in-person tour.
Yeah, we would love to organize that when COVID calms down a little bit, because we all need to experience the actual bathroom ourselves to see the yes, for sure. Yeah. Okay, so be mindful of time. Thank you so much, and I hope you will join us next Monday. Until then, stay safe and see you soon. Bye. Thank you so much.
You're welcome.